Hey guys, this is Mr. C, and in this video, we're going to be solving some linear inequalities. So in this one, I've got some examples here for you. And so the first one, we see x plus 3 greater than 9. And so for this one, we're going to treat this like an equation first. Subtract 3, cancel that out, bring my x down, greater than 9 minus 3 is 6. And so it turns out that our solution set is all real numbers greater than 6. So if we need to graph that solution set, I'm going to be showing you this too, just to make sure you guys know how to do this. If your professor or teacher gives you a number line with numbers on it, that's fine. I'm going to use blank ones. So the only number that really needs to be on here is 6. And then all real numbers greater than 6 would be an open circle at 6, because it doesn't include it. It doesn't have a little equals part. And greater than, if the variable's on the left, greater than 6, we would shade everything on this side just like that. Hopefully you guys can see that. And that's what the graph would look like. So each of these I'm going to graph it too when I get done, just so you guys know what the graphs look like. Okay, these are going to work up in difficulty. So this one, we have a fraction over here, x minus 1 over 2 less than or equal to 4. What I would do is I would take the 2, or even better, multiply both sides by 2. Those will cancel. X minus 1 is now free, and that's less than or equal to 4 times 2, which is 8. Now I just add 1 to both sides, and we see how these look a lot like equations, the process. Bring my x down, less than or equal to 8 plus 1 is 9. All right, what would the graph look like for this one? Well, let's go ahead and take a look. So on the graph, the only number I have to have on there is 9, and I usually put those right in the middle. Less than or equal to is going to be a filled-in circle or closed circle, and it is less than, and so it's going to be shaded this time to the left. Sometimes teachers will go up and over on top of the line. I don't do that. I shade directly on my number lines. It's just my habit. And then that's it for that one. All right, so here we have one, two-step. 2x plus 5 greater than or equal to 7. So we're going to solve it just like an equation. Take 5 away from both sides. Cancel those guys out. Bring down my 2x. Still the same symbol. 7 take away 5 is 2. Divide both sides by 2. And we get x greater than or equal to 1. All right, so let's go ahead and graph that solution set, because the answers to these aren't just one number, that's a span of numbers, many, many solutions. So it's going to start at 1, and it does have the little equals part there, which means it's a closed circle, shaded to the greater than or equal to, shaded to the right. And so we're going to shade that to the right with a big arrow right there, and that's what the graph looks like for that one. Okay, so we have another, I would say, two-step. This one's going to be a little bit different though, because I see that negative in front of the term with the x. Add 4 to both sides. Okay, bring down your negative 3x, less than 8 plus 4 is 12. Now we have an issue. Whenever you multiply or divide both sides by a negative, notice I did not say add or subtract. I said multiply or divide, like this. Negative 3, negative 3. These do cancel. You do bring down your x, but the symbol now flips. And 12 divided by negative 3 is negative 4. So you need to pay attention to that. Whenever you see a negative in front of x, that term right there, generally that means somewhere down the line you're going to have to flip that symbol. I said generally, but not always, because you could have some stuff over here that will make a difference. All right, so let's graph that solution set. So this one, the only number I need to have on this number line is negative 4. Okay, it is an open circle because that's a strict inequality, and it is greater than, so we're going to shade to the right. So you can always use this, the way the symbol is pointing to shade, whenever the variable is on the left-hand side. If the variable is on the right-hand side, then you'll have to do something, one extra little step, before you can use that symbol to decide which way it's being shaded, either to the right or to the left. All right, so here's a multi-step inequality. This one, I'm going to go ahead and subtract 5 on both sides. And so those cancel. I bring down my 2x less than or equal to x, and then 3 minus 5 is negative 2. Okay, so that's just what I chose to do first. I could have subtracted x on both sides first, but I chose not to do that. Subtract x, subtract x. Now you have to do that because you're trying to get x by itself on one side. Cancel those guys out. 2x minus 1 would be just 1, less than or equal to negative 2. X is positive, less than or equal to negative 2. And then we're going to graph this. And I want you to notice on this one, just because you see some negatives in a problem doesn't mean you automatically flip the symbol. You only flip the symbol if you multiply or divide by negative. And we did not do that here for this one. So I need to have negative 2 in here, less than or equal to, so that it would be a closed circle shaded to the left. And so we'll shade that over here. And there's your graph. All right, let's take a look at this one. Another multi-step. Okay, this time, before I can even get anything going here, I need to distribute this negative, this minus. So I've got 2x minus 4x, and then 2 negatives make a positive, so plus 1 greater than 17. Okay, 2x take away 4x turns out to be a negative 2x. So as soon as we did that, we see that there's probably going to be a symbol flip in there somewhere. Plus 1 greater than 17. Okay, but we're not going to flip it yet. We're going to move the 1 over, bring down my negative 2x, greater than 17 minus 1, 16. Now the last thing you want to do is flip it twice. We're only going to flip it one time at the end. Divide by negative 2. And we did divide by a negative, so we are going to take that symbol and flip it. And now we get x less than negative 8. Okay, we're going to go ahead and graph that. So on our graph, we need to have negative 8 on there. And it's all real numbers less than, strictly, so we have an open circle. And we're going to shade to the left. And that's it. Okay, this one. Both sides have parentheses, so we're going to have to distribute on both sides first. There. So we're going to have negative 6, x over here, minus 9, less than, okay, let's distribute over here, 10, and then negative 6x. So now I'm interested because I see I have a negative 6x on both sides. So instead of moving the 9 over like I would normally do, I'm going to add 6x to both sides and see what happens. So what happens is all of my variables cancel, and I'm left with negative 9 is less than 10. So the question now is that a true statement? And negative 9 is definitely less than 10. That is true. Since that's true, you're going to have all real numbers for your answer. Every single x value you plug into this thing will be true. So all real numbers or you could write the symbol for all real numbers, which is like that fancy looking R right there, and either one of these answers would be okay. Now, if that was a false statement right there, then it would be no solution. But it's true. And let's take a look at this last one. Okay, this one looks like we need to distribute over here first. So the left side, we didn't do anything, but this side is going to be 8x and then minus 12. Now, I'm looking at that now and I'm seeing the same exact thing on the left side and the right side. I can just stop right there because no matter what x value I plug in, the left side and the right side are going to be equal. And so what that tells me is that since it's greater than or equal to, and I can keep going if I want. As a matter of fact, negative 12, greater than or equal to negative 12. Is that true? It is true since you have that little equals part. If that equals part wasn't there though, negative 12 would not be greater than itself. So this one is also true. So for this one, since it's true, you're going to get all real numbers for your answer. Easier just to write the symbol, and then we're done. But if that was not a true statement again, then you would have no solution for that one. So just a nice little quick video on solving some linear inequalities. Remember to like and share, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.